Java programs, which is like the whole name of this entire game, right, this semester. We want to do multi-threading in our user interfaces, in our graphical user interfaces, so that we can do all those really basic time-consuming tasks and put them in the background. So it means that the user always sees one thing in the front. That thing should never hold, stop, pause, show the little curly, spinning wheel of death. We should always make sure that that runs smoothly and everything that takes a long time is sent to the background. So you'll see some things do that kind of successfully. Some games I've played, before they load like a mini game for you to do as like a little stupid Pac-Man kind of thing, and you trace like a maze around until it loads the next thing. Or some games, most of them nowadays, they just show you a video. So as you're going from one level to the next, they transition you into this video that you're watching. That video is their way of keeping you busy while they load the content, because it's a heavy task, into the next thing. So it happens all the time. Metal Gear Solid could be better at it, but we'll pretend like that didn't happen. What we do want to do is make sure that thread confinement is a little bit better at its job, and data is only accessed from one thread. And so we're going to refer to this as thread confinement and say that every time we access some of this data, I want to make sure that everybody has the right access at the right times. This is exactly the same conversation as we just had with regular Java and being thread safe. Same thing with bank accounts. Multiple people accessing the same bank account at the same time. It's just different now that we have a user interface, trying to decide, does the view get it, or does the model get it, or whatever. So we want to make sure that we follow the MVC design pattern, and it'll help us be thread safe by guaranteeing that all our data is in one place, it's in our model, and the user interface is in one place, it's in the view, and it'll help us kind of separate some of these things out. What we're going to want to use in javafx for concurrency, instead of the java.util.concurrent stuff, we want to use javafx.something. So they're also called concurrent, but it's under javafx package. And we have three things. Again, it's really two, because you don't really need one of them. But we're going to have a worker class called, it's an interface. And then we have two things that are sub-things, that are implementations of worker. So I don't really use worker, I use one of the types of workers. This is kind of like list and array list and queue list or whatever else you want. We're never really going to use worker, we're going to use either task or service. So task is going to be an abstract class that designates the task that we want to run. Service is going to be an executor. So just like we had our threads before and our executor and our pool, we're going to instead have things in javafx that are named just slightly different, called task and service. Same idea and the exact same thing that we want to happen in the first place. Now our worker class has a bunch of states that it has access to for each one of our tasks. So when I talked about regular Java and threads and how they get started and queued, schedules, and then they're running, and then they're terminated, and they're paused, we get all that same stuff, except the worker class actually has, it's an interface, actually has all of these static values for the current state of your task. So you're going to take your task in a nice little task object, give it to the worker. It's going to be a worker by itself. It's going to get executed. And then you can say, hey, task, what's your state? And it's going to come back with one of these constants. And you don't even care what these are. It's not a string, it's not an int, it's not anything that you care about. It's going to come back and tell you one of these things. So if it comes back and says, failed, in capital letters, you have a pretty good idea of the state of your task right now. You're never really kind of guessing on these things. So you can check each one of these things. You can move it through and see whether it failed or succeeded. If it was canceled, for example, canceled is going to mean interrupted, just like the other one did. So if your operating system interrupted your process and canceled something, your task, for example, then you're going to have access to these. So these are something that we generally skip over in the Java API. Whenever we Google a class, we skipped over a lot of the constructor and the class variable summary. We went right down to methods. So that's where the cool stuff was for the Java API. But these are actually at the very top of it, where it's kind of talking about different static values that it has. They're not static necessarily, but final values. All right, so implementation. So let's say I have a reader task, and it's time consuming. It takes a really long time. The only changes I want to make to it are to extend task and to tell it what type of task, and we'll talk about the type here in a second. But my thing takes a long time, whatever I'm doing takes a very long time, so I'm going to extend task and I'll implement the string call method. So call is going to be the name of the method. This string return type is the same as your task generic. So whatever I'm going to be returning from call, so whatever it is that takes a really long time for some reason, in this case it's just going to be a string that apparently takes a long time to generate, is going to be the type of task that I'm going to be creating. It's also going to be the return type on my call method. I'm going to have a string result in this case and do a whole bunch of things in here, maybe read some stuff in and return some sort of result. So let's say I had like a 100 gig file and I'm reading through it for something very specific and I'm doing it very poorly because I'm not checking to see what line it's on very efficiently. It's just taking a really long time. I put all that in where this comment is, and then once I finally found it, I'd return whatever I was looking for. And this whole thing would run in the background. So I'd kick this off, it would search this really long document for some reason, and then return back the thing that I was looking for. So that string could be anything. If you were looking for a music file, say you were digging through somebody's library and they just had 100,000 songs, and you're looking for some exact song, you're doing it very inefficiently. You'd want to kick it off in the background and kind of do it this way. Once you have this created, once you have that previous class created, you kick it off by using a thread. So you can wrap your task in a thread. So I would have created a new task object called task in this case. I'll put it inside of a thread, which is also in javafx.concurrent. And then I can go ahead and execute it by saying th.start, which is the same way that we did before for like single-threaded applications. Or I can go ahead and add it to the executor service API, and that's just like the executor service we talked about with multi-threading. So you're adding it to a pool. So if you just have one thread, one background task, maybe you don't need to add it to a pool, but you might as well let him swim by himself if he needs to, in case you need to add other tasks later on. So usually you won't do this top one. Instead, you'll create your task thing and you'll say executor service.submit task. You don't have to create a new executor service. Executor service is a class that's there just to help you out. The submit method is a class method. So this is the only line you need after you've created your time-consuming thing. So whatever that is, go ahead and kick it off afterwards. All right, so if I want to cancel something, let's say I kicked off a background task and it's just taking a really long time and never found that right song or never found that piece of information, and I want the program to go through and say, listen, you took 20 minutes, you're done. The guy won't get his song, I want to cancel something. I can ask for it to be canceled, but I can't promise it's going to be canceled. So my program's going to request it to be canceled from the operating system, and the operating system's going to say whether or not it wants to. Basically, if it can or if it needs to force it or anything else. So there's a best practice in javafx tasks to keep checking and making sure that they're not canceled just yet. So where you'd usually check the state, and you check to see have I failed or succeeded, you're also checking to see if it's canceled yet. Because if you just check to see if it failed or succeeded, you won't know if it stopped in between, because it's technically not failed if it was canceled. So there's a nice method called isCanceled. So that's it. So instead of saying, is my task succeeded or failed, I'll check to see if it's canceled first, and then I'll check to see if it failed or succeeded. All right, so there's an example on the course website that's kind of built to do this. Really basic example program. We're going to create a new JavaFX project to do this, and I already did this because these are things that I think I'm fairly confident you could do a few of these steps on your own. So creating the JavaFX project in Eclipse, you're good at that by now. Creating an FXML for the GUI, you're good at that too. This is our GUI. It's going to be a box with a button at the bottom and a text field in the middle. And that's it, text area in the middle. So you can create this in Scene Builder pretty easily, pretty quickly. I connected them to the controller, so there's a main that shows this. This is a FXML, and then there's a controller that connects to it, and there's a label at the top that says static, or status right now. And then what we want to do is write a method that takes a long time printing, and that's the part that's a little bit more interesting. So I'm calling this one JavaFX concurrency example 1, because, you know, I'm creative. And our main method looks like this. So we have main extends application. We have a start, where we're starting things up like we usually would. I kind of condensed some of the code. So if you're looking at a condensed version of being able to show an FXML, this is actually more accurately what you'll see in the real world. This is how I write my stuff if I write desktop applications, which is not very often. I mean, this is very valuable. You'll have 3 lines. You'll have one that loads the FXML document, one that sets the scene, and one shows the stage. So more accurately, this is what your whole main is going to look like every time. This is it. Instead of lots of lines of code like we usually have, we're just loading one thing at a time. So we have the main. We also have main view.fxml. We just kind of saw a preview of that. The interesting part is going to be main controller. So main controller is going to have an FXML tag for a status label and an FXML tag for a text area. And then we have a handle method connected to the button. So every time the user hits the button, it's going to kick off something, and I have 2 options for you to kick off, and you want to uncomment one of these 2 things, so that's why there's a to-do here. So runtime consuming task is going to be a method that runs something that takes a long time. So again, it's going to be wasting time while it shows you something, but instead of system.out.print, I'm going to update the status label. So at the top of the screen, we get to see what it's doing right now. And then append something to the text area so that you get that running list of what's going on. So it's kind of like system.out.print for javafx. So let's look at the code for that. So run time consuming task, print something out to the console so we can kind of see it going at the same time. We can kind of keep track of stuff. And then it has a for loop that just runs through, counts from 1 to 10. It says processing, and it puts the processing blank of 10 into the status label, which is at the very top, and it appends it using append text to the text area. So I'm going to keep getting that printout, kind of like a log almost inside of my thing. And then in here, we're going to call thread.sleep. So sleeping just takes a long time for no apparent reason, and it takes this thread, this task, and puts it to sleep for some amount of milliseconds. This is going to be about 1 second. So very exciting, but it should take just enough time to look like something really crazy happened. So we'll just run this time-consuming task. We can update some of these things. I'm going to clear this out. I'll hit run. That's not what I wanted to run. I wanted to run this. So I'll run it as a Java application. This is our beautiful app. We're going to want this status to change. We want some text to be added in here when I hit the start task button. So I hit it, we can see it's running. I get the beach ball of death, and more beach ball of death, more beach ball of death, and then all of a sudden everything's here and it's done. So we didn't get to see this top part here, the status change up here. We just got the very end message. We didn't get to see the in progress, so it kind of adding lots of things together. So it's kind of the equivalent of Netflix saying, let's load your movie for like an hour, and then be like, the end. And we're done. So not you know, the best movie experience ever. So instead what we want to do is introduce some of this multi-threading, or some of this concurrency at least. Even if we don't have multi-threads, we do here, but I'll talk about that in a second. We just have concurrency kind of going right now. So all I want to do is, every time I kick off this thing, and if it's going to take a long time, especially if something sleeps for some period of time, go ahead and make sure that my GUI, my user interface, doesn't freeze and show me the beach ball while the user is looking at the app. So to see that demo, you want to go back to the controller. Up here in handle, there's only 2 options. You can either run time-consuming task, which is without threads, or run threaded task, which is also time-consuming, but it has threads in it. And let's see the behavior that we're looking for first, and then we'll look at how this works. So I'm going to hit start task again. It's the same app. But this time I can see the top is changing. It says 4 of 10, 5 of 10. I can see things being added to the screen. This seems like a better user experience than just everything at once. You know, and every time I run this, I'm going to get that same experience. I'm always going to count, you know, slowly it's going to be appending to this, you know, so I'm going to slowly get more and more appended to it. But as things change, I can kind of see this going through. And what's really nice is I'm in javafx, so I have this scrollable pane automatically, so no matter how many times I can always read it, and it looks kind of good. So this is the experience we want. We want this threaded experience, and actually this is multi-threading because there's one thread being run for your user interface. That's something that we've already been kind of relying on. Now we're creating another thread and running it concurrently to be able to do this background task. To be able to do this, I added some code down here called run threaded task. So that was the method that we're calling. It prints out what it's doing first, and then it creates a new thread here, and it creates a new task inside of that. So a new task, if I hover over this, it's going to tell you a little bit more about it. Oh, it's a raw type. It's just going to complain, right? Right. It's a new task with a type of string. Happy now? There we go. Now, if I hover over it, you can see it's from the javafx.concurrent.task, location. So if you look at task.java, it's actually an interface that you're going to be able to see. So we're actually creating a new version of this, but we're also implementing the code for this task in place. So this is my way of sneaking in anonymous inner classes into this curriculum because I don't want you to focus on it, but if you see it in the real world, you might see this a little bit later on where somebody's creating something like this. So this part of the line kind of makes sense. Thread th equals new thread. Open parentheses, it's calling the constructor. This part's kind of weird, right? So we're creating a new something inside of it, and it's opening up a curly brace. When we open a curly brace, it means it's creating something new, and so this curly brace must end somewhere, and it ends all the way down here, and here's the semicolon. So let's open this up just a little bit more so we can see it. So this entire line of code, right here, is one line of code. And it's creating the code that you need for a class. It's not naming that class, it's creating a brand new anonymous object with anonymous inner class. It's defining the code for a brand new class inside of this object creation, which is super weird. This is what we call anonymous inner classes. If I want to call this code again somewhere else, it means I'd have to recreate that code, which is annoying and why we don't actually do this that often. But if it's just a one-time thing where I'm just creating something very short, maybe like this or shorter even, anonymous inner classes are handy because I didn't have to create another something.java and then create another object of that sort. Again, this is a little bit too much for this course. You don't need this, but when you see code like this, you should at least be able to follow that. This is another class that's getting created. This is creating a new task, just like we just talked about, and that means for task, I need a call method of some sort. So it's creating a new task of type string, the same way that we did on the slide. So that means this type string here has to be the return type of my call method, and it's going to do something that takes a long time. So to take a long time, again, we're going to count from 1 to 10, same thing that we did before. We're going to say that we're processing blank of 10 in the process. And then instead of doing thread.sleep, which we're going to do down here, we're going to use something called platform.runLater. This might be something in your team projects. If you're really having trouble and you try the multi-threading process and it doesn't work, you might need this platform.runLater. What it's doing is it's basically kicking off a separate JavaFX task or thread or process for you to be able to do something in the background so that the user can see it. This is really important for getting access to things that are on the graphical user interface. So in this case, all I'm doing inside of this run later is creating a new runnable. So this highlighted area is, again, another anonymous inner class. So I got anonymous inner class inside of it. This is like horrible programming, but this is all over the internet. If you're looking at examples of concurrency and multi-threading online, you're going to find some horrible code. People do terrible things with threads. It's ridiculous. But if you piece through it a little bit line by line, you should be able to make sense of it. And hopefully this clarifies things just a little bit. So I've got a task that takes a long time. It's going to call. Call's going to call platform.runLater. Platform's going to get access to your operating system, your JVM basically, and ask the platform to run something for you. And that something's going to have to access the user interface of whatever the user's seeing. So at the time, all they're seeing right now is maybe that status text and that text area. And so to be able to do that, it'll call run, and I created a separate method for set status. All it's doing is setting the label and the text area. So we could put that same thing in there, but it kind of gives us a cheat for it, so I can get to it later. And then we sleep again, and we return some of the status. This is less useful returning the status. Let's go up to set status. So set status, all it does here is it takes in text, and it puts the same text in the label as it appends to the text area. So we're doing the same thing that we were doing before, but just to separate some of the task logic from what you need to do. All right, so then we're going to be creating the thread itself and kind of running it. And again, it's going to give us that smoother kind of interaction there. So let's pop back over here. All right, so when we're running the time-consuming task, I kind of broke it out too on slides. So if you want to go back over this later on, it's kind of broken out a little bit piece by piece instead of looking at the whole thing. But this example, I'm going to be able to share with you guys. So you'll be able to see that, you'll be able to see kind of how this kind of runs. And then another one is kind of the time-consuming task. We talked about that one too. This is about inner classes. And so there's two different kinds of inner classes. We're going to have inner classes that have names. So you can actually create a class, two classes in the same file. So let's say you have example1.java. And that's the name of your class, example1. You can also have another class inside of that that's named, you know, inner class 1 or something. And then you can have them both in the same file. It's not a very good practice, but it can be practical if you want to be able to access things from inner class 1 inside of example1. Or you can have something like this, which is called an anonymous inner class. And it's going to be something that doesn't have a name, that's why it's anonymous. So just some extra terminology in case you see some of these things. Second demo we want to look at is javafx using the same concurrency thing. And this time we're going to create the start task, but instead of printing a bunch of stuff out, we'll use that progress bar. And so the progress bar, when you first load it, it actually just, it looks like this. The thing, the blue guy, just kind of pops back and forth like it's waiting patiently for you, and it just kind of goes back and forth, back and forth. When you hit start task, it should start filling the progress bar as it's fulfilling the task and running all the threads. And when it's done, it means all the threads are done. And if I click in the meantime this read task state, it'll tell me what the state of the task is. And that should always be that big all caps word. So either failed, all in capital letters, or hopefully succeeded every time you run this demo, which is probably more accurate, or running if it's still kind of in that state. So if we want to do this, we need to build the GUI for it. But the biggest thing is going to be that task, right? So the biggest thing is going to be the multi-threading. It's not really going to be building that GUI. That GUI wasn't that exciting. You just have this, and then you drag and drop a progress bar onto it, because you're not building this stuff from scratch. Drag and drop two buttons and connect your controller. The task, though, is going to be a little bit more interesting. And again, if you want to create the anonymous inner class for this type of task, you can create a new task. And then open and close curly braces. So this is one declaration for your new thing. Your task is going to be created once. You can't create a second object of this now, because we've already kind of written the code. You'd have to copy and paste it. But if I just have one thing, so just have one progress bar, it's not so bad. I'm going to go ahead and create a call method inside of it. Once I do the new task, it's going to make me do call anyway. So if you try this in Eclipse, it's going to force you into creating that call method. My call is, again, just returning a string. Most of the time, you're going to return something that you probably don't need. In this case, I don't need it. I'm just creating a progress bar, so I don't really care about that. It's going to waste some time again. I'm going to go from 1 to 50. I'm going to keep checking to see if the task is canceled. So this is a safety kind of thing. So this goes back a little bit to our exception handling and stuff. If in JavaFX you need to be a little bit safe about your application, if there's a chance that something could get canceled or the user could do something or something bad could happen, I would want to, for safety's sake, check to see is canceled. And there's nothing that needs to go inside of that if statement except maybe break. So stop doing what you're doing if it is canceled. And is canceled is going to be called on this. So you can say if this dot is canceled, and it's checking this task. So there's no other implementation. I don't have to implement is canceled. It's already kind of there for me. And then I can do anything I need to do in this update, so make any changes to labels or messages or anything else that I want to change. Probably the progress bar change I should add in here, so I should get access to the progress bar thing from that fxml tag. So progress bar dot, status or whatever, update it to some amount, and then it's just going to sleep again for some period of time and then keep going. So that's what we want our demo to kind of look like, and this is what the concurrency should look like. Actually updating and calling this kind of thing is going to look like this. So I'm going to have a button somewhere. Usually I don't do this. I don't say button B equals new button. We usually drag and drop it on Scene Builder, right? But the code for this concurrency demo, I actually did the other way. So I did it completely without fxml. Because you might see that too. And if you ever need an example, it'll be there in the GitHub repository. You'll be able to refer back to this. So this whole thing's built without fxml. So we actually have to create the button in Java, and to do that, we create a new button. I'm never going to ask you to do this because I don't like this kind of code, but you're going to see this, and it's going to be important maybe that you do this if you do touch fxml or javafx in the future, out in the real world. You would create a new button instead of using Scene Builder, and then you'd actually, to be able to link it, you'd call certain methods on the button. So the methods are always set on action, spoilers. Instead of in your Scene Builder, kind of linking the controller to the document and linking the handle to that, whatever button, you're going to set an on action and create a new event handler. So this is not using MVC. We're kind of creating our C, our controller, right here in the space as an inner class, anonymous inner class. So instead of creating a C controller, we just have a new event handler that takes in an action event that looks just like the way that I usually implement the event handler, or extend the event handler. I never remember. And then we created a handle method inside of here and do something. And in this case, I want to kick off my task that we created in the previous slide. So go ahead and throw task in there as something that was previously created, kick it off, and that's all I want to happen every time the user hits start. So it should kind of start that new task. We had a second button though, so the other button was to check the status of that task. So the other button, I'm going to have to do the same thing, create a new button, and then a new set on action with a new thing where it's going to be listening. That's not what I wanted. All right, so this one's actually going to be in javafx concurrency demo 2. I could put them in the same project, but it gets confusing. You get lots of different classes in the same place. So there's 2 different classes, and I'm going to go ahead and upload them to GitHub before we leave. But the concurrency demo 2 actually is a little bit more involved. So if I don't use fxml, it means that my main still extends application, still the thing that gets run, but you'll notice that there's no fxml document in here. I do have a main controller in here listening to some things, but I'm going to be initializing the main controller in my application. I can call setup on it to initially set up some stuff, so let's look at main controller.setup, and it actually contains lots of the view components for it. So we're not really following MVC here. It's not great code, but it's setting up some of the view without using Scene Builder. So instead of fxml tags, I have something to set up the box that I have stuff in. So if I have maybe a display, the border pane kind of set up, in this case I might just have a VBox. I can have my task that's going to be running. That's going to be the thing that's in javafx.concurrent. And then a bunch of stuff for the GUI. So a progress bar, a few labels, and a few buttons. One label is going to show the counter, how much time there is or how much has passed. One label is going to show the state when I ask for the state. So it's kind of like that error message that we created before, where if the user did something wrong, we'd show the label. But if the user hasn't done anything wrong yet, or if the user hasn't hit the button, they don't see that label to begin with. So let me run this main so we can kind of see this again. So when you have a new progress bar and you've added it to your view, it's actually just going to kind of kick back and forth like this, just kind of waiting on you. Depending on your operating system, there has been one operating system that doesn't do this. It just kind of sits and waits for you to push the button. Most operating systems, Windows, most Linux environments, and Mac always do this. If I hit begin task, it starts to count. If I hit check task state, it tells me what the state of the thread is. I can hit it as many times as I want while it's counting. It's always going to tell me running. But now I can hit task state and I'll see succeeded. So if I begin task again, nothing's going to happen because I've already kicked off it once and it was only listening for that one thing. So it's kind of a one-time sort of app. But it uses a progress bar that's kind of here. We have a label here for it counting, 2 buttons and another label down here. So in our main controller, it's going to add that kind of thing up. So when we call setup, it's going to create our task for us. That's the code from that previous slide. After it's set up that task, so this task thing that was initialized, it's a global variable, class variable up here, we're going to do the UI building. So this is the UI building when you don't have Scene Builder. You have to create each one of your items and initialize each one of those things and kind of put them in the right order. So I have a progress bar that I initialize. I set its progress to 0 to begin with, and then I bind it to a property. So if I want to connect my GUI component to something that would usually be in my controller, like a handle method, I need to actually bind it to it, using code instead of just typing handle in that side menu. So I'll bind it to a task using task progress property, and this can be task message property, binding it to the label so I can update the label later on, and a state label which will be updated later, and I'll update the button and set that on action. So this is the code from that previous slide as well. So we're setting an on action for an event handler, so on and so forth. The moral of the story is that we spent a lot of time in FXML and made things really easy in Scene Builder, dragging and dropping things on there. That's a good way to code. That's good code. You want to separate things into model view controller. You don't want to be doing this because this leads to a lot of confusion, a lot of no WYSIWYG, right? So in order to see what this looks like, I have to run the code. What I see here is code, and that's not what I get. What I get is a full application. So I want WYSIWYG. What you see is what you get, drag and drop things, make sure that they look right, and then run it, and it should work properly. So adding a whole bunch of state here, this is kind of a little bit more of an example. So these two applications, JavaFX and Java Concurrency Demo 2, I'm going to go ahead and I'll share them. So I'm going to go to Team Share Project. We can note a repository. I'm going to go ahead and add it to summer2018.get and hit finish. Just going to think about it. And I'll do the same to Demo 2. So I'll add these both to summer 2018. I was going to think about it. All right, we'll do it later. My internet's been amazing. If you want to add music, the thing that I wanted to kind of point out, we were kind of talking about background tasks and things that were going to take a long time. You actually don't need to follow all these steps to be able to do media or music. So if it turns out all you want to do, your time-consuming task, instead of counting to 50, or doing something else that takes a little bit longer, if it's just music or media, and we want it to operate properly, we can insert it using a few lines of code. And I want to give that to you in case you want to add music to your team project, if you've been kind of struggling with this or you just want to make this work properly. You want to use the media and media player. So those are actually built into JavaFX, and they can play music, they can play videos, they can play whatever you want, kind of. But you want to create a new media, give it a new file. So maybe I have the Pac-Man theme, as a WAV file that I just want to kind of include in my project. If I want to go ahead and play that whenever the user creates or starts the program, I'm going to create a media player here for it, and then a media view. So the media itself is the data. The media player is the thing that's going to handle the data for me, kind of like Scanner handles your data from the file. And the media view is going to be the thing that handles it on the GUI thread for Java. So we're multi-threading, but we don't have to worry about threads and tasks. This is all the code you need, which is great. So we've got all the pieces we need, data, player, and a view. I need to add the media view to the scene. So in here, inside of the main.java, we're actually going to have, where we're setting up a scene, we're adding the scene to the stage. We're going to go ahead and say scene.add media view. And then after you do primary stage.show, I'm going to go ahead and call player.play. This is really important to do it after you show the stage because the user needs to see the app first and then play the music. If you do it before that, it's going to play the music entirely and then show the user the app. Very frustrating. I get a lot of emails about this one. So you'll want to kind of do all these kind of pieces and throw these in there, but you can go ahead and kind of add this in. And if you just wanted to see this in Pac-Man, I actually added the stuff to GitHub so that you could save the file. So I added pacman theme.wave. I don't know if I can play it or not. Oh, iTunes, really? That's your choice. So it's going to play this like the whole time on loop, which is terrible. But it's something. So if I have main.java, and I actually want to have this kind of running and stuff, one thing I need to do is I need to change this load next view so that it doesn't actually kind of do this every time. I wouldn't want it to keep loading the music and playing it on different threads. Then I'd have that playing with another thread playing and another every time I load a new view, and that would be very frustrating. So I'd actually have to break this back out, put the code in here, but the code that we're looking at, this media player and media view, all of that can go at the top where you load your fxml, so it could go in here, for example. And then you need to add the media view to the scene, and you would do that once you have a scene, so maybe here, so you could say scene.add media view, right? And then after you've shown the stage to the user, you can say media view.play or player.play, and the player will go ahead and load that data for you. So you don't have to do all of this worker, service, thread sort of, or task kind of stuff every time you need threads, because usually the API's wrapped it in something for you. But just so knowing how it works is really important. So this actually kicks off the thread that you need. It handles everything for you. You don't have to really worry about it. And it works every time as prescribed. And the code for playing a video, pretty much the same thing. And the code for doing lots of other things in javafx concurrently, pretty much the same. You want the same components every time. You need the data, something to play it with that acts just like a scanner. You can envision it like a scanner. And then the GUI component, the view. All right, so we still have stuff to talk about on Wednesday. We're going to talk about Lambda expressions, a little bit about Lambda calculus, and just so that you can kind of be up to date on Java 9, Java 10, all the new Java stuff that's kind of coming out. But I just want to make sure that you guys knew about the exam and the information about it so I can hear about it now if you have a problem.